Okay, the topic for today is graphing parabolas. And this equation that you see at the top of the page is one way to write an equation for a parabola. And actually, this form is called vertex form. We can write equations for parabolas in different ways. There's vertex form, standard form, and factored form. We're going to focus today on vertex form. In a couple of days, we're going to be graphing them in standard form. And, all right, let me explain to you what this means. First of all, this graph right here is the graph of a parabola. This is a quadratic equation. And what it looks like is a U. Agree? That's all it is. Every quadratic function and every quadratic equation graphs this way. Now, here's the thing though. Sometimes they could be flipped upside down because remember, when we have transformations, they do flip different ways around the x and y axis. You'll see that right here. This one is right side up, and I've got another one right here that is upside down. So it either looks like a U or like a mountain. They won't go sideways. All right, so this is, and they're called parabolas. This one right here that you see at the top of the page is the most basic one. This is y equals x squared. All right. This graph has some important features. It is symmetric about the y-axis. And what that means is that when you look at the y-axis, the two sides are mirror images of each other. The left side is a mirror image of the right side. Always true. Therefore, the y-axis is called this parabola's axis of symmetry. It's the line through the parabola where both sides are mirror images of each other. Every parabola has an axis of symmetry. Now, if you look in the middle of the page here, this is a parabola. I won't tell you which one because it's not really marked on here what the vertex is, but it is a parabola, and its axis of symmetry is right here. It's not the y-axis, but it is right here. Whenever we graph a parabola, one of the things we're going to want to find is the axis of symmetry. All right? The point where the parabola crosses its axis of symmetry is the vertex. That's right here. It's either the lowest point, or if it's upside down, it's the highest point. This is called the vertex. And the coordinates for the vertex are h, k. And those are the h and the k that you have in the vertex form of an equation for a parabola. All right, if we go down to the bottom graph here, this is the graph of y equals ax squared. It's concave up. Concave has to do with the curvature of an object. All right? And when we say concave up, we mean this opens up. Down here, this is concave down. It opens down. So why don't we label that so we know which way our graph is going to look. This is concave up. This is concave down. Now in our equation for a parabola, if A is positive, and let me remind you where A is, it's right here. If A is positive, this is going to be concave up. If A is negative, it is concave down. So when you're working on your homework tonight, one of the first things that you're going to have to figure out is if A is positive or negative, so that you know whether your parabola is concave up or concave down. But it's easy to figure out because it's just right there staring you in the face. So while this one is y equals x squared, this one that's upside down is y equals negative x squared. Okay, I have a lot of parabolas on this particular graph. This diagram shows the effect of the value of A on the shape of the parabola. And this parabola has the vertex 0, 0. So h and k are 0, so it's just y equals ax squared. All right? If you look at this really skinny one in the inside, this is y equals 2x squared, very skinny. And if you look at the bottom here, the upside down very skinny one is y equals negative 2x squared. The larger that a number is, positive or negative, the skinnier that parabola is. But look at the real fat parabola. This is y equals 1/2 x squared. So if a is between 0 and 1, positive or negative, this is going to be a fatter parabola. And so you can see the fat upside down one is y equals negative 1/2 x squared. So let's go back here. As the absolute value of a gets closer to 0, the parabola gets wider. As it gets larger, the parabola becomes more narrow. All right? That's just something general that you should know, so that when you're graphing, you have an idea of how yours is going to look. But we're going to find some specific points on our parabola so we know exactly where to draw it. So if you go to the graph at the bottom of the page, we're going to talk about some things. First of all, we've got this parabola right here. This is the vertex. All right? This line right here, the axis of symmetry. The points where the graph crosses the x-axis are the x-intercepts. There may be 2 of them, there may be 1 of them, there may be none of them. It will always have 1 y-intercept. Never 2, never 0, always 1. If we can identify the y-intercept and any x-intercepts that we have, it's really going to help us draw this graph. So that's part of our goal. We want to identify these characteristics so we can draw a very good graph. All right. Now, unfortunately for us, at the top of this next page, the hole punch fell right on my H. So what was here is a 3. I know, isn't it funny? Okay. So this parabola happens to be y plus 2 equals x minus 3 quantity squared. Now, this comes from the form y minus k equals a x minus h quantity squared. So from this, we're going to get 2 things. Well, actually 3. First of all, the number in front of the x minus h quantity squared, you don't see one, so it's a positive 1. That means a is greater than 0. So this is concave up. The next thing, this is the h, this is the k. But remember, in front of them are minuses. So we're going to identify what h and k are. Since we have a minus, the h is 3. So the vertex, which is h, comma k, in this case is 3. -2. And it's -2 because we have a plus here and not a minus. So our vertex is 3, -2. So far, everything we've done, really easy. All right, so we graph the point 3, -2. We know that's our vertex. We know this is going to be a U shape because it's concave up. The next thing we're going to find is our axis of symmetry. Now, when we find an axis, it's a line. So it's going to have an equation for a line, but it's a vertical line. And if you remember from our unit on lines, vertical lines have the equation x equals a number, right? It's x equals h. Not h, x equals h. All right? So in our case, this is x equals, and h is 3. So our axis of symmetry is the vertical line through 3 on the x-axis. So I have that kind of drawn in there. You can see that. Now I know where this is going to fall. But something that will help me even more is if I know my x-intercepts and my y-intercept. I'll have specific points that I can graph that will allow me to draw the perfect parabola. So let's go to this box in the middle of the page, and it's going to tell us how to find everything we need to find. If you have a parabola in vertex form, let's remind ourselves, this is vertex form. If a is greater than 0, it opens upward. If a is less than 0, it opens downward. First important thing you need to know. The point HK is the vertex. That's either the high point or the low point, depending on whether it is right side up or upside down. The line x equals h is the axis of symmetry. Not just h, but x equals h. Now, in order to find the y-intercepts, remember, a y-intercept is the point 0, y. In order to find this point, we're going to plug 0 in for x in our equation. That's all we have to do to find this y-intercept. Set x equal to 0 in your equation and solve for y. Now, to find the x-intercepts, remember, x-intercepts look like this. They have a 0 here in the y position. So all you're going to do is set y equal to 0, and you're going to solve for x. It may give you one solution, it may give you 2 solutions, but let me tell you what, if you get an imaginary solution, which is going to happen from time to time, that means there are no x-intercepts if you get an imaginary solution. All right? So what we're going to do is go through some examples, and we're going to graph these from start to finish. And here's our first one. We're going to go through all the characteristics that you need to identify. So here's my equation. First of all, does this open up or down? Well, there is a negative in front of the x minus h quantity squared. So this means a is less than 0. So this is concave down. Now, the vertex is the point HK. Our H has a plus here in front of it. That means this is a -2. We've got a minus in front of this 5, so that means a +5. So our vertex is -2, 5. So let me graph that right here. That's our vertex. And this is concave down, so I know it's going to look like a mountain or an upside down U. And that means it's going to have 2 x-intercepts. We know that right now. It's not going to have imaginary x-intercepts, and it's not going to have 1. It's going to cross somewhere over here and somewhere over here. The axis of symmetry is the equation x equals h h is -2. So this is the line, x equals -2. And I'm going to go ahead and draw this in here. And remember your skills at graphing lines. X equals -2 is right here. And I'm going to actually label this x equals -2. I'm just going to write that on my line. So I know that the left side of this graph and the right side of this graph are going to be mirror images of each other. Now, to find the y-intercept, set x equal to 0 in our equation. So I have y minus 5 equals -0 plus 2 quantity squared. And I'm going to solve this from here. All right, so first thing, on the right-hand side, 0 plus 2 is 2. Square that, and I get 4. It's got a negative in front of it, so I have y minus 5 equals -4. Add 5 to both sides, and I've got y equals 1. That means my y-intercept is the point 0, 1. And I'm going to graph that. Now, I will show you. Here's something you can do. Remember how the right and the left side of this graph are mirror images? You know you're going to have a point right over here. That's my mirror image point. Now we're going to find the x-intercepts. And to find the x-intercepts, we are going to set y equal to 0. So here's what I've got when I set y equal to 0. I've got 0 minus 5 equals negative x plus 2 quantity squared. All right, what I'm going to do to solve this, and you will find that when you're in vertex form, this is the easiest way to solve this. We're going to go to that completing the square method, and what I want to do is I want this by itself. So I'm going to divide both sides by -1. And I get 5 equals x plus 2 quantity squared. At this point, take the square root of both sides. And I have, remember, it gives you two answers, plus or minus the square root of 5 equals x plus 2. Now just subtract 2 on both sides. And here's what I've got. -2 plus or minus the square root of 5. Those are my x-intercepts. Now, I need to put those in decimal form, obviously, because I have no idea where to graph this at this point. So, let me put these in my calculator. -2 plus the square root of 5 is going to give me 0.24. So I've got 0.24 comma 0 as one of my x-intercepts. Let me do -2 minus the square root of 5. And that's going to give me -4.24 comma 0. So -4.24 maybe fall around there, and +0.24 around there. So here's what I've got. I've got a lovely graph with enough points on it for me to make a pretty parabola. It's all of this work that students usually don't do when they're trying to graph these on the homework, which is why I gave you the document I did, so you can reference all of this. All right, let's do one more example. Okay, so here's another one. First of all, does it open up or does it open down? Well, here's the A. The A is greater than 0. So this is concave up. All right? The vertex is HK, which in our example, here's our H, so it has a plus in front of it, it's going to be -1. Here's K, since it has a plus in front of it, it's going to be -6. So I can go ahead and graph that. -1, -6, right there. This is really easy. I know that axis of symmetry is going to go right through that point. The axis of symmetry is x equals h, which in our example means x equals -1. And I'm going to go ahead and draw that line. All right, now, I know that this is going to be opening up, so it's going to have two x intercepts and one y intercept. So first of all, to find the y-intercept, set x equal to 0. So I've got y plus 6 equals 2 times 0 plus 1 quantity squared. 0 plus 1 is 1. Square that, you get 1 times 2 is 2. So y plus 6 equals 2. Subtract 6 from both sides, and you get y equals -4. So my y-intercept is 0, -4. And that's right here. And remember, this is my axis of symmetry, which means there's a mirror image point on the other side. So I can draw that in. The last thing I'm going to do is find my x-intercepts. This is where we're going to set y equal to 0. All right, so we have 0 plus 6 equals 2 times x plus 1 quantity squared. And remember, the method that's easiest to use here, some of you will still choose to do the quadratic formula. Let's do the tail end of completing the square because it's set up beautifully for that. Divide both sides by the 2. And I've got 3 equals x plus 1 quantity squared. At this point, square root both sides. That's going to give me two answers. Plus or minus the square root of 3 equals x plus 1. Subtract 1 from both sides, and that will give us -1 plus or minus the square root of 3. All we need to do is put this in decimal form. So -1 plus the square root of 3 gives us 0.73. So 0.73 comma 0, and then we've got minus. -1 minus the square root of 3 is going to give us -2.73 comma 0. So 0.73, maybe about here between 0 and 1, and -2.73 here between -2 and -3. All right? And that allows us to draw our parabola. And the interesting thing that you may have noticed, this is a skinnier parabola, correct? And that is because the number here, A, is greater than 1. The bigger this number is, the skinnier this parabola gets.